Good
Therese.
evening. Yeah, good evening, everyone. Hi, I'm Therese Glowacki, and I'm the director of Boulder County Parks and Open Space. First of all, I want to thank you all for joining us tonight. There are over 100 people that signed up for this scientific panel on integrated weed management. This panel consists of independent experts outside of Boulder County government who will discuss the threats posed by invasive weeds, efficacy of different management tools, the potential risks to soil, water, or human health associated with herbicides, and the opportunity cost if herbicides are not available in the toolkit to manage invasive weeds. Throughout this panel discussion, we will discuss research, share practical insights, and discuss effective science-driven solutions for mitigating the negative effects of invasive weeds. We look forward to having a thoughtful discussion to provide valuable insights into the complexities of invasive weed management. We are nearing the end of our year-long process to update our integrated weed management plan. We've taken Parks and Open Space Advisory Committee out on 4 field trips, and we've held 7 public hearings with POSAC that included experts on goat grazing, cheatgrass, herbicide labels and safety, counterpart agency approaches, and our draft plan. The final hearing at POSAC is March 28th at 5:30. It'll be in person or virtually. And then the county commissioners will hear this on April 16th at 3:30. Your comments submitted to the Integrated Weed Management Plan website are being shared and read by both POSAC and the county commissioners. So you only need to submit comments once. Please be sure to check our website for future updates. And with that, thank you to our panelists for joining, and thank you to our county commissioners and our POSAC members who are also here to engage in this thoughtful science panel. Thank you.
Thanks, Therese. My name is Sarah Alexander. I am Vice President of Programs for Keystone Policy Center. Boulder County has asked us to help moderate the conversation tonight. We are a Colorado-based organization, and we are a nonpartisan, non-advocacy organization whose mission in life is really to bring difficult discussions to bear with the best available science and community values to get to credible solutions. And so we are honored to be a part of this panel today. I'm going to walk through a little bit of our agenda and ground rules, and then we will get started. I'll also introduce my colleague, Mallory Huggins, who's helping us with the moderation, and will be monitoring the questions and answers so that we make sure we can get as many questions answered tonight as possible. We are going to be hearing from 4 experts tonight, which is only a handful of the many kinds of expertise that may be available to this complex topic. So in some ways we will be just scratching the surface, but we're really lucky to have 4 great experts to do that with tonight. So we will be hearing from those experts, which I'll introduce them in just a second, and then we will have some questions and discussion with them, and then we'd like to take as many audience questions as we can for the second half of the agenda today. So, and thank you to those of you who shared your questions with us in advance of the call today. We will work on addressing those to the extent we can as well. So before we jump in, I just want to share some ground rules, both with our panelists and with the audience. So again, we want to create and share understanding. So we're going to ask our panelists to limit the use of technical terms or acronyms or explain them when they do. We don't have time to cover everything in depth, so the panelists know I have a rabbit hole warning that we'll use if we are going too far down any particular area and need to redirect to make sure we get as much information out there as possible. We, again, as I mentioned, have a few areas of expertise represented, but not all. And so we've told the panelists that if they don't know the answers to some of these questions, that's okay, that they just need to acknowledge that. We are recording this. It will be available through Boulder County after the fact. And we are also going to be sharing links to any reference studies after the webinar, so you all can take a look at those. We've also asked the panelists, when they're referring to studies, to share whether or not they've been peer reviewed or under what process they've been peer reviewed. So that was one of our advanced questions. We will take questions from the audience. You will be able to do that in the Q&A. You can see the other questions that are being asked, and you can upvote them if it's a question that you would also like to have the panelists address, so that we can get a sense of making sure we're answering the most burning questions for you all. We will also organize some of those questions by theme to kind of group them, so that, again, we can get to as many as possible. And we do reserve the right to delete any questions that are inappropriate or disrespectful to the panelists or other audience members. All right, so without further ado, I'm going to introduce our first three panelists. And I'm not going to read their full bios that were circulated in advance, but I will give a brief overview. And we've asked the first three to provide just an initial kind of 5 minutes each of opening remarks about their work and research in this area, and some of the questions that we know that are top of mind for folks. So we are going to start with Dr. Tim Seastedt, who is a CU Professor Emeritus in terrestrial ecosystem ecology, and who's worked on grasslands for over 40 years. We'll then hear from Dr. Scott Nissen, who's a CSU Professor Emeritus with the Colorado Water Center, and had his PhD from Montana State, and has done a lot of work in plant, help me out here, Scott, plant management and agroecology, correct? Oh, Scott is muted. Mallory, I don't know if you can unmute him.
Scott, I've prompted you to unmute.
There you
go.
Okay. So I don't want to take up a lot of time, because we all have long pedigrees, but did my PhD at Montana State, some postdocing at UC Davis, came to CSU after several years at the University of Nebraska, where I worked in the Sandhills with a colleague, USDA colleague, and came to CSU in 1986, and just retired. Shout out to Tim on his recent retirement. So that's it's a nice position to be in.
Great, thanks. And then we'll hear from Dan Tekiela, who, in addition to being a PhD, is also works in the land management business for the U.S. Forest Service. So we're going to ask Dan to talk a little bit about how he applies some of the research and science that's available to this topic and the work that he does locally for the Forest Service. And you all are welcome to correct anything that I just said or expand on that in your opening remarks to the extent that I gave you short shrift on your background. So Tim, we'll go ahead and start with you, if that's all right.
Okay, well, I want to thank the county for the opportunity to participate in this program. And what I'd like to do in my intro here is to explain my science approach to weed management and why this approach is becoming what I think is mainstream for the 21st century. You know, as stated in the overview, we've got a bit of a controversy or uncertainty regarding the extent to which pesticides are essential for successful weed management. And what I'd like to do is explain the science requirements for a non-chemical, science-based management approach. My approach comes from my training and background as an ecosystem ecologist. The ecosystem ecologist is one who studies entire landscapes, the plants, animals, microbes, soils, and the climate that impacts these communities. And if you give an ecosystem ecologist the task to assess the impacts of a weed, that individual will likely measure factors such as plant and soil biological diversity. And an example is some of our work our lab did over a decade ago. We studied the impacts of cheatgrass on plant diversity at a site next to a Boulder County open space. And we reported a strong negative effect of cheatgrass cover on local plant diversity. Our early findings supported the Boulder County contention that cheatgrass has reduced local plant diversity and therefore was potentially worth proactive management. But this work indeed was published, and it actually has been cited about 140 times in other publications. And ironically, this study wasn't cited in the original draft of the county weed plan that's been presented this year. And the point here is that community ecologists and weed scientists move in very different circles. But for the most part, we're involved in different professional societies, and it's pretty obvious we clearly don't talk to each other. And so clearly that's part of our problem. So the ecosystem ecologist is often asked, why a weed becomes dominant in a particular community, and it'll concurrently ask, what's the impact of this species on the community? And point out it's the impacts that are important, not necessarily the abundance of the weed. Ecosystem ecologists can also reverse that question and will ask what species like plants, animals, microbes in the community can impact the weed, and can these be manipulated to reduce the impact or harm caused by the weed? The other academic trait I bring to this problem is my association with the long-term ecological research program. Since 1980, scientists have been doing experiments and monitoring species abundances and responses excuse me, across the country. And here in Boulder County, they've been doing this before I got here. But this monitoring effect is an extremely valuable approach to assess, first of all, climate change responses, but monitoring also can measure the number of species coming into and out of the community. I've used this approach when I became a weed manager back in 2001, and I emphasized that monitoring has been absolutely critical to understanding both climate and management effects on plant communities. Ecosystem management guidelines are kind of the Bible of ecosystem ecologists, states that if you're not monitoring, you're not doing science-based management. So that said, our county managers have got a huge amount on their plates, and we've not seen any monitoring data associated with the county programs. There are short-term experimental findings. But to understand the impacts of the weeds listed in the Colorado State list, you really do need decadal scale monitoring in order to understand if the weed is truly invasive and problematic over time. And further, this monitoring could tease out the effects of climate, natural succession, disturbance, and management on weed impacts. After 30 years of working on this in this area, I'm confident that this ecosystem ecology it does form the scientific framework for weed studies going forward. Thanks.
Thanks so much, Tim, and for staying on time. Dr. Nissen, we're going to go to you next. And I think you maybe had some slides you wanted to share as well.
Yeah, if I just click on share my screen, will that work?
That should work.
All right, let me find it here.
That should do it, Scott. Let us know if it does.
There, yep.
Okay. Ooh, come up. Okay, unlike Tim, I'm in need of visual aids in order to stay on track. So that's why I took a few slides. I only have like 10, so I should be able to get through them pretty quickly. I guess I would agree with Tim. We don't talk to each other very much. People who are ecologists, community ecologists, and that's probably detrimental to both of our disciplines. As a weed scientist, we're obviously more interested in direct management and doing that management in a way that's as ecologically friendly as possible, but also we're interested in outcomes. Just talking about cheatgrass specifically, this is certainly a weed that's changed the whole ecosystem of the West.
I'm just going to hop in and interrupt you.
Yeah.
Sorry,
Okay.
We are seeing your slides, but they are flashing, which is odd. One thing I want to see if you can do is just to switch. You see a button above, and if you can swap displays, because we're seeing your notes screen rather than the slides. And I wonder if that will jostle it into no longer flashing.
Okay, you're seeing the
There.
okay, swap.
Yeah, we're seeing. I don't know if that will stop the flashing, but up in your upper left, there's an opportunity to swap displays.
Okay.
You could try clicking that.
Does that help?
Now, oh, there, yep, that's better.
Okay. So now, okay, are we good now?
I'm seeing a black box on your screen. Do you have a zoom? Are they seeing a black box?
Yes.
That's just my screen.
A black box.
Okay, I think it might.
Now it's all black.
Okay.
Now it's all black. Scott,
All right,
let's just try one. The age-old practice.
There you go.
I was going to say we could restart, but actually, here we go. This seems to be promising.
Yes.
Okay.
We can see your screen now, so just go back to slideshow mode.
Okay. Better or worse?
That is
back to black.
Yeah, why don't we, if you want to just go
if you're comfortable, we can do it, just not in slideshow mode. And you can go back to what you just showed us and we'll see the slides, but they're smaller.
Yeah, I think that's the right answer.
Go back to slideshow mode. It's what I'm in.
No, escape from that.
Off of slideshow mode, rather. Here we go.
Okay. There you go.
Yeah, because we can see this. Yeah.
Okay.
I think this is the best we've got. Sorry for interrupting you.
Oh, it's all right. That's all right. And I would also say that, fire has been one of the driving forces, and there are many ecosystems in this part of the world that are not fire adapted, at least for the fire frequency caused by cheatgrass. And if you look into the Great Basin, for example, that entire ecosystem has been impacted by by cheatgrass. So I would also say that there's some consensus between ecologists and weed scientists that cheatgrass certainly influences fire frequency and intensity. The competition caused by cheatgrass is kind of explained by this slide, which shows two weeds competing against each other. We all know how competitive kochia can be. But in the presence of cheatgrass, this slide shows that that area in the middle, downy brome or cheatgrass, was outcompeting the kochia. And you can see the difference between the kochia that's competed with the cheatgrass versus the kochia on the sides. And you can imagine that if a native perennial grass or forb was under the same level of competition, you would have the same response where the plants would have a very difficult time of surviving. And so we began, thinking about how do we manage cheatgrass on a large scale, not just, a few acres here or there, but millions of acres. There's somewhere around 55 million acres of rangeland that's been infested by cheatgrass. You can look at EdMaps and you can see all the data there. But we started looking at, well, how long does the plant seed survive in the soil? Because that could be a key characteristic of management. We've done some field studies. I'm showing a manuscript here that was published in Rangeland Ecology and Management, where basically we showed that the cheatgrass seed survives maybe 3 to 4 years in the soil. And that's sort of what we were looking at as the lifespan. And there are many weeds that last much longer, and we could go into that as another focus. What I wanted to talk a little bit about, because this has basically been generated, the whole discussion, by the fact that there's a particular herbicide the county would like to use. So I wanted to go through some of the basics of how this all came about. And actually, the herbicide was never intended for rangeland use because the companies didn't feel there was enough financial reward. There was Bayer, the company who developed the product. It was looking at crops in Southern California, vineyards, pistachios, almonds, walnuts, those kind of things. We noticed on the label in 2010, when this product Allion or Indaziflam was released, that cheatgrass was on the label. And so in 2010, we started researching the potential of Indaziflam to be used in perennial systems like our shortgrass prairie. So with that, we developed some very interesting results, more and more positive results over time. We presented those data to Bayer, trying to convince them that they needed to get a range label for that product. And That's about a $10 or $15 million investment, which is where we are right now since we have the range label. Before that, it could be used in open space without domestic livestock. Eventually, Bayer spun off that non-crop business, and most people, or some people, may have heard of Enview, which is the new product or the new company. And the shift in the paradigm is we have a product that works by essentially producing a layer of treated soil in which the cheatgrass is trying to germinate. The herbicide does not affect germination. It simply stops the development of the first radical, or the coleoryzal. So that's the paradigm shift. We can protect all sorts of perennial grasses, shrubs, forbs that are perennial as well. And that's
Scott,
where
we have just a quick minute to finish this up, and then we can come back to some of these as well as.
Okay, I only have 2 slides
questions.
left. Okay, so this is just some of the titles that we have published over the years, and we can provide all of those. We've done a lot of, or done some reseeding work and had excellent success. This just shows field site near Nunn, Colorado. The product could also be used with aerial applications at low gallonage. This is out near Sterling. And you can see the strips of cheatgrass versus the treated. And so just really from my standpoint, it's more about management and providing land managers with options that they can use to manage cheatgrass.
Wonderful. Thanks, Scott. Next, we're going to turn to Dan, who's going to share a little bit of his perspective about being a land manager and a scientist in this space, and how he goes about balancing all of these complex issues.
Great, thanks. So I think I kind of balance in between Tim and Scott in that I came from a background of invasion ecology. So I came from an ecology lab that was not interested in management at all. They were interested in understanding kind of ecological principles with invasive plants being their study system. And from that point went on to the world of management when I took a position as a professor in an extension role, where really in extension, the question is always, what do I do about this landscape, right? Not necessarily just monitoring, but taking action for some type of desired outcome. So I kind of am in the middle of the two of them in I think my perspective of that. I take a great interest in trying to identify as many tools as we can use for any particular management scenario. And I already saw a question. I'm very tempted to like just focus on the question, so I already had to redirect to giving my little spiel here. But trying to identify the best tools that we can use for the particular job. And I've done work on, for cheatgrass in particular, Pseudomonas florensis was a biological agent, a soil bacteria that was purported to potentially be a control agent for cheatgrass. I've looked at micronutrient fertilizers for cheatgrass control. I've looked at targeted grazing for cheatgrass, among other target species control. I've looked at using nursery crops for cheatgrass control. And I'm saying all this to say that I'm not just trying to use herbicides because they are the only option that I have experience with. I've as a researcher, looked at lots of different strategies trying to manage cheatgrass. I will say the scales that were present in Wyoming, where I was an extension specialist, and frankly, along the Front Range, none of these strategies that we had were particularly effective at the scales that I have interest now as a Forest Service manager, where we're working with thousands of acres, and any land manager, county level even, is going to be working with quite large scale management. I want to give just the perspective of how we make decisions in management, given the realities of the information that we have available. So I just gave a talk recently where I was describing the balance that we strike as managers in decision making. And it's the balance between what I call the wild, wild west, which is the go out there, do whatever you want, throw caution to the wind, no safety, no monitoring, as Tim mentioned, the get her done mentality. On the other side of that is the really safety precautionary principle approach of don't do anything, take your time, do all the research for every single location that you're going to take action on, have decadal type information to be able to respond to that particular system and what your goals are for it. And neither of those two things are realistic. If you're in the wild, wild west mentality, you can do just as much harm as you can do good. If you're in the precautionary principle of never take action until you have absolutely every piece of information you need, we would not be able to have landscapes that are as healthy as they are, because we wouldn't be managing them for the goals that we have for them. So I wanted to cover that. The other thing that I constantly am reminding myself of in the invasion world, and Tim kind of referenced this a little bit, I think indirectly, is invasive plants in particular, are they the drivers of change, that whole idea of impact, and they're changing that system as a whole, or are they just kind of along for the ride, and it's really something else going on about that system that has led to the presence of that invasive issue? So that paradigm is called the passenger driver hypothesis, and understanding our weeds just passengers of disturbance already happening on the landscape, and if we just leave it to be healthy, it'll return to a desirable state, or are we in a situation where that invasive plant is a driver of change, is actually changing that system? And often what we see, at least of the species of the Western US, and particularly the Front Range, is a lot of these species, all evidence points towards them in most cases being the drivers of change. And therefore you have to take some type of direct action to tweak that system back into a more desirable state. One of the first steps tends to be remove that species from that system. Whether it be trying to use a herbicide, which I think is going to be the primary discussion point here, or some other strategy. We've just found through lots of research and lots of management actions that at the scales we often need that tweak to happen to bring that system back into a desirable trajectory, tends to be a herbicide.
Great. Thanks so much, you all, for providing years and years of background in 5 minutes or less. So I know it's difficult, but do want to turn to some questions for you all now. And something that, Tim, you touched on a little bit, which is, how do we know if how climate change is influencing these systems and these issues and the spread of noxious weeds? And how everything from the spread of invasive species to, how the landscape is storing carbon or not storing carbon, and how might these change the way we manage weeds going forward? So does anybody want to go first with that, or I'll call on you?
Is that your second question? I'm just sorry, you rephrased it.
Yes, it's the second question, Tim.
Okay,
sorry.
Well, in that case, I'll be glad to go if that's okay.
Yes, go ahead.
So, our grasslands in the Front Range have come through mega droughts. They've survived decades of extensive overgrazing from the first European settlers. And for the last 7,000 years, they've been adapted to frequent fires. These species are tough. And my monitoring efforts suggest that in larger analyses done at CU as well, that the contention that plant species are at risk at landscape scale extirpations due to invasive weeds is unlikely. And it's certainly now confounded with climate change impacts. There will be exceptions. There's always exceptions, but these can be identified and treated when they come up. The reality is we are in a climate crisis, a crisis that, is accompanied by an invasive species problem. So our priorities, in my mind, for natural areas must be preparing and, insofar as possible, mitigating the next extreme event that's coming our way: wildfire, drought, or flood. Within this context, then, weed problems can and should be addressed, but they should be subsumed in a land management program that's primarily aimed at actions that contribute to climate resilience. So I suspect that many of our listeners are well-versed in nature-based climate solutions, and they know that it's possible to use our native landscapes to promote climate resilience, local cooling, and greenhouse gas removal. To me, that's the top priority of management. In doing those activities, I think many actions can also be used to control invasive plant species. A good example is a recently published paper that was generated through the Nature Conservancy, sponsoring the Gunnison Sage Grouse Project. There, they used re-wetting projects to increase the abundance of native plant species while not benefiting the invasives, which are a problem out there. And of course, they appear to have achieved their main goal, which is benefiting the threatened Gunnison sage grouse. So our labs, been involved in studies in plant species diversity and patterns of soil carbon storage. We can show a lot of relationships, many of them very positive. We've looked at how invasive species affect things like carbon storage, and again, responses are variable. But as a general priority in Boulder County, at least, we want to favor, in my mind, if you want carbon storage, you want to favor our warm season grasses to as best as we can. And to do that, the technique is to use rewetting techniques as being done now in Colorado by groups like Wildland Restoration Volunteers. In terms of climate resiliency, I'm often asked which plant communities are the best. And as you can imagine, any short answer is an oversimplification. But in managing for water retention on all of our natural terrestrial surfaces will likely generate the best response. Any management that dries landscapes, causes increased runoff, or dries the surfaces is not going to be beneficial. In the foothills, our ponderosa savannas should perhaps be our dominant and most abundant community type. These are fire resistant and resilient, and they're also top candidates for carbon drawdown and soil carbon storage, and pretty good at fighting invasive species. Thanks.
Great. Thanks, Tim. I saw both Scott react a bit, and we have a question about what you mean by rewetting.
Oh, good. I was going to ask the same question. I have no idea what that term means.
Well, actually, right tonight, another seminar or a webinar is going on by Ellen Wall, who is the guru of the beaver dam analog and rewetting bottomlands program. What we've done out in Craig, Colorado, and helped with the TNC at Gunnison, Colorado, is the upland rewetting program. And it's essentially the same technique, and it's legal under Colorado water law, which is you can slow water, you can't dam it. But if you slow water moving across gravity-fed landscapes, it's better at soil water storage, and the outcome is really obvious and very quick. The plant productivity is stimulated, and in the case of the Gunnison data, which is, like I said, that's the first published report we've got of this out in Colorado, to my knowledge, it benefited the native species.
It seems to me that's a very small area that could be impacted relative to the 55 million acres of cheatgrass that we're dealing with. It sounds like a great, if you're in a drainage or you have a stream that you can impact, that sounds great. But what about all the upland sites?
Well,
and what about all the other areas that you've mentioned? And I would say I'm not a climate scientist, but I think there's pretty good evidence to suggest that a perennial grass or any kind of perennial system is better at storing carbon than one that's dominated by annual grasses. And so I think one question we may be overlooking is the fact that we don't really have any analogous species to winter annuals that are invading the Western U.S. We've not only got cheatgrass, but Wyoming's got ventonata, we've got medusa head, several other winter annual species, and there's an open niche. And so as long as that niche is available and we occasionally run into disturbances and fire, for example. And while I would agree the Front Range has been, many of the plant communities are somewhat fire adapted, they're not adapted to the fire frequency that we see when we have this fine fuel that's produced by cheatgrass. And I think there are some properties in Boulder County that show that when people have tried to do prescribed burns as a management strategy, the intensity of the fire is strong enough that it's actually caused damage, if not death, to many of the perennial shrubs. So I think this, there's, like you said, there are exceptions to every rule. Your rewetting idea sounds terrific, but to me, it sounds very limited in the scope that it could impact.
If I can just very quickly hit the rewetting.
Sure, and then we'll bring Dan in.
The cheatgrass when we get to the cheatgrass question. But first of all, riparian zones are responsible probably for 85% of the species we have in Colorado. Everything.
Yeah, totally agree. Yeah.
And in the Gunnison sage grouse, it turns out that very small patches of wet meadows provide the essential food supply for the baby grouse, so they tell me. And this is all what I read. This is not my science. But essentially, you can do powerful things in small areas. As much as I love our upland grasslands, in terms of ecosystem values, drylands are pretty low on the totem pole relative to anything we can wet up and make productive or minimize the extent to which water limits the productivity of the system.
Great. Dan, do you want to jump in?
Yeah, that's a perfect point to jump in. I guess from an ecosystem service standpoint, those dryland grassland systems are one of our predominant systems for carbon storage. So yes, the diversity of things they might be doing might be lesser so than what's happening in those wetter riparian type systems. We depend on those grassland systems to retain carbon. And even being the Forest Service guy, I will admit that per acre, perennial grass systems are pretty darn effective at storing carbon, even relative to our coniferous systems. So, you know, being that that's a direct effect on climate change is the ability of that system to hold carbon. I think that's worth mentioning in the context of this. And just to reiterate what Scott said, that when you have an annual grass system, it's kind of a double whammy if you do have fire coming through because you don't have any below ground carbon sequestration, or at least not really meaningful carbon sequestration. So it's all sitting there, whether it be in that thatch layer, that fine fuel thatch layer, or in the live plants themselves. Fires are going to readily burn that, and that means all carbon storage that occurred via that annual grass system is being lost to the atmosphere again. So I think that's a significant impact directly on climate.
Thanks. I know we just, again, we could teach a semester course on any one of these questions, I realize, but thanks for those quick answers on that. And I know we did have a question in the chat about weeds in addition to cheatgrass, but also that a lot of questions are, or a lot of the emphasis is around managing cheatgrass. So just want to give you a second to share a little bit more about what we know about the ecological impacts of cheatgrass in the West and in Colorado in particular. And, you know, to the extent we can be as specific to the context of Boulder County, I think the better. Recognizing contexts are important in this space, but anything you all want to share just about kind of what we know about. Scott, you all have shared a little bit about that in your opening remarks, but just want to give you a chance to take that one on a little more directly if need be. So Scott, do you want to maybe start on that one?
Yeah, I would just say that over the years we had weed tours every summer, and they got popular enough we would load up 2 of the CSU team buses and take people around various sites, many of which were in Boulder County because of the level of activity that the Boulder County program has generated over the years. And I don't have specific data. I could provide pictures, which are always really nice to look at. But when you remove, this is assuming the site has some remnant natives left. When you remove the cheatgrass, people are very surprised by how many, the response of the perennial grasses and the perennial forbs and even the annual forbs for that matter. And I think there's quite a bit of data that's been generated by Boulder County. So I'm not going to try to remember all the different sites that we visited. Hall Ranch would be one, and there were several others. I don't know the names of all the open space properties. But the response of the plant community, once you remove the competition from the cheatgrass, were fairly profound. And lots of native forbs came back. Productivity was way up. You know, many of the pollinators, that seems to be another big thing that people are interested in. We don't often realize that many of our native pollinators live in the ground. They don't have hives like we think of bees. And without that open ground between the bunch grasses that sometimes is occupied by the thatch of downy brome, there's very little places for them to nest, and there aren't very many floral resources. So one of the things we had a woman here at CSU who did a pollinator study for Boulder County, and I think that data has been published. I don't know exactly where, but it was pretty obvious that when you control the cheatgrass, you increase the diversity of flora, you increase the diversity of plants that are flowering, and plants have more flowers than they do when they're in competition with cheatgrass. So I know that's a little rambling, but there are many impacts, positive impacts for controlling cheatgrass. And I think Boulder County Open Space Program can provide plenty of examples from some of their properties that they manage where they did cheatgrass management and saw some pretty phenomenal responses, not only from native perennial grasses, but from forbs as well.
Dan, do you want to jump in, and then Tim will give you the last word on this one?
I will admit that for a lot of my personal research occurred in Wyoming, which I guess if you're to look at the spectrum from the Great Basin into Wyoming, Front Range kind of exists somewhere in between there. We can say with certainty Great Basin reductions in plant diversity, often to a monospecific system, i.e. just the invader, where there's nothing else left but cheatgrass or the other annual grasses. I found similar things in my work that in almost all cases, the presence of cheatgrass had a reduction in diversity of the vegetation. If I can make a leap then in other research that exists, and I can't point directly to it, I'd have to go back to a lot of my work as an instructor. There is ample evidence to suggest globally that vegetative systems that are more diverse are more resistant to disturbance and change, particularly climate change. So inherently, I would argue in most cases, by having that diverse system, both by species and functionality, you're positioning yourself better for the coming changes that we are already feeling of climate.
Thanks. Tim, go ahead.
Okay. Well, there's a lot of generalizations about cheatgrass out there that are true, but there's also a lot of these generalizations are sort of site or context specific. And I just want to briefly mention those. So the reason cheatgrass is really nasty to biodiversity in the Great Basin, like Nevada, is because cheatgrass does indeed enhance the fire frequency out there. It's the frequent fires and not necessarily the direct competition from the plant that seems to harm the native biodiversity. Studies out there testing plant competition effects, really show that cheatgrass is not a very good competitor, and that's consistent with our work as well. It's got into the community primarily by cattle disturbance, overgrazing. It will occupy bare spots at a moment's notice. And then once it fills in, it's got that fine fuel mat that'll carry fire across very large distances. But here in the Front Range, we have always had frequent fires. Tom Veblen's work suggests a fire return interval of once every 10 to 20 years running up our hillsides. And the hottest cheatgrass fires that would occur is when it senesces out and is still upright, which is probably July. If you look at our record of wildfires in Boulder County over the last 20 plus years, we've had one wildfire, I think, in July, and it was up in Nederland. Our mega fires occurred during the non-growing season. And those non-growing season fires are carried by our native or perennial or other species, certainly other than cheatgrass. So unlike the Great Basin, cheatgrass does not have fire here as its ally in harming biodiversity. And then two experiments that we've done in our lab have shown that the seasonal pattern of precipitation in the Great Plains, something we're adjacent to, reduces the abundance of cheatgrass, while the seasonal pattern of precipitation in the Great Basin, Nevada, enhances cheatgrass cover. These empirical findings support the models that are out there developed by the cheatgrass researchers themselves. In both of these very different ecosystem types, cheatgrass does indeed dry out the soil by the 1st of June or thereabouts. But the big difference is in the Nevada, the Great Basin, it's a winter wet system. It does not get much in the way of summer moisture. And so competing plants after June, when the cheatgrass is dead, have got nothing to grow on. In contrast, in the Great Plains, if you look at our general rainfall pattern in the Front Range, we are a spring wet, summer wet system. So cheatgrass again dries out the soil, but this time there's water to be had, and the competing perennial, long-lived grasses can get in there and eventually squeeze out the cheatgrass that got in there via disturbance in the first place. And so our work, I've worked with a colleague, Dr. Janet Privé, And she's demonstrated that cheatgrass really can decline over decadal periods in the Front Range. But yeah, you got to wait a decade. So it takes patience, and you can't demand, instant gratification for this process. And during those years of decline, the abundance of the grass, we know of no additional harm, because if it's done damage, it came in when it was most abundant. And ironically, during that harm, our data suggests that the beast is pretty good at storing carbons in the soil. And ironically, it's pretty good about defending the prairie against invasive earthworms, which are all European in origin. So very strange results, not necessarily something you'll find that'll happen outside of the Front Range. So cheatgrass entered our systems by disturbances that we now can control or mitigate. Without those, I don't think cheatgrass is a major problem, and the managing for plant cover alone should suffice. The only one-term, long-term data set we've got in Boulder, says this can work, and just that instead of being proactive, we'd be passive in the management of this and watch. And the data would suggest that we risk very little during this time period while this is occurring. It needs to be tested across more of our Boulder landscapes.
Great. And we do have a couple questions saying that they'd like to broaden this conversation beyond cheatgrass. So Dan, you had your hand up, but
yeah, I'll acknowledge, I want to acknowledge this conversation first, and then I'll try to add my 2 cents about other species. So it's not published data, but I actually was on the committee of a student who was doing work directly on fire dynamics with the presence or absence of annual grasses, primarily cheatgrass in this case, on the kind of eastern edge of Wyoming. So going into warm season grasses, sagebrush steppe, kind of that mixture, somewhat similar to the Front Range. And I just wanted to counter what Tim was saying, that, where the intensity occurs is during that time when it's still upright but senesced. And we found that that might be the case, but even during the fall and spring seasons, trying to do prescribed fires, that the intensity was far greater in systems that had that cheatgrass thatch layer and had major implications for, particularly on the sagebrush steppe, where the sagebrush itself was not fire adapted to that, but also into the farther eastern systems, warm season grasses, and had a greater negative impact. So I wanted to just comment on that. In terms, I know there was one specific question broadening it out specifically to the toad flaxes. Funny enough, in terms of actually killing a plant, cheatgrass is maybe one of the easier plants to control from that standpoint. Because it is an annual plant, you're really just fighting a seed bank. When it comes to something like Dalmatian toadflax or yellow toadflax, you're now fighting a perennial plant that has a fairly substantial root system, and you're having to both control the plant and its seed bank, and that becomes far more difficult. And I can say things like so I did a lot of work on targeted grazing for Dalmatian toadflax in particular, and after 3-4 years, still seeing very, very little control. So the expectations of the level of control you need to get it to be able to try to decrease that abundance and actually open up that system for other plants to exist is pretty high, and in a lot of cases unattainable for general managers doing that type of work, that targeted grazing work.
Great. I'm going to take the opportunity here to bring Diana into the conversation. Also, just reflecting some of the questions here about how are herbicides used, and some of the questions around, are they, what are their impacts on wildlife, other biodiversity other than just the weeds themselves. Diana comes to us from Cornell, who's done a lot of work to look at how to create decision support tools in this space of using herbicides, pesticides in a way that is responsive to the concerns around toxicity, both to human and ecological communities. And so Diana is an entomologist by background and an expert in integrated pest management. So I'm going to ask Diana to share 5 minutes with us, and then we have a question or two for her, and then we'll open it up to the broader sets of questions as well. So Diana.
Thank you.
Thanks for joining us late on the East Coast as well.
Are you able to see my slides?
And just it says you've started screen sharing, but we don't see an actual slide at the moment. We may just need to give it a second.
I try again, but it says your screen sharing is paused.
Hey, it wasn't just me.
Yeah. Mallory, do you want to see if you can help us troubleshoot here real quick?
Yeah, I'm looking at some settings I can change. In the meantime, Diana, if you'd like, you could send me your slide deck and we can see if I can share it.
Try again one more time.
Okay. I don't think it's paused on my end in any fashion.
There we go. Okay, now we can see them.
Third time.
Cool. So yeah, good evening or night, everyone. So I'm Diana Obregon. I'm a postdoc at the New York State IPM program. I am an entomologist, and my background is mostly on studying how insecticides can affect bees. So it's not really related to weed management or herbicides in particular. But I joined the IPM program with the purpose of working on the environmental impact quotient. That is a tool that was developed 30 years ago, but we are in the process of revamping the tool and updating the tool. But it's still pretty widely used in different countries, in different states here, and by different type of companies. So for example, McCain Company, the potato retailer, use this tool to help the growers reduce their pesticide risk. And I'll give you more information in a minute. So this tool is not to decide if you want to use pesticides or not, but if you decide to use pesticide after, of course, a careful discussion about it and weighing other measurements, and if you decide to use an external input, let's say not just conventional pesticide, but any external input, you would need to think about it and make a risk assessment. And when you think about risk assessment, risk is a function of two things. So exposure and toxicity, because you could have something that is very toxic, but if you're not exposed to it, there's no risk. And on the other side, you can be exposed a lot to something, but if that compound is not toxic or mildly toxic, maybe there's a very low risk. And to estimate risk, there are different approaches. And sometimes people just depend on how much information you have, right? And you could get some information based on the amount of pesticides that you use, but that's not enough information of risk, because not all pesticides are created equal. Not all are equally toxic. So it's important to have information on both the toxicity, but also the exposure. So for that, there are some things called pesticide risk indicators. And what they do is that they link hazard or toxicity with exposure data and pesticide use. So for example, the OECD, they created a database of different pesticide risk indicators, and one of them is the EIQ. And these pesticide risk indicators are tools that you can use to choose or recommend among pesticide options based on their potential risk to non-target organisms. And they could be also helpful to measure the sustainability of a management program, and also to track pesticide risk in time and space. And in particular, the EIQ, as I said, was developed 30 years ago, but Joseph Kovac from the IPM program, and it's a calculation designed to indicate pesticide risk for farm workers, including the applicator and the people who might work afterwards, the consumers and non-target organisms. And basically the equation is this one, and it's designed to weigh different information on toxicity and exposure. And as you see, the inputs that you need to do the calculations are chronic toxicity to mammals And right now you can see my notes. For chronic toxicity, we are considering evidence for carcinogenic effects, endocrine disruption, reproductive and developmental effects, if it's a neurotoxic or it's a genotoxicity molecule. We also consider dermal toxicity, how long the residues are on the plant surface, on the soil surface, if the product is systemic or non-systemic, the likelihood of leaching, fish toxicity, the runoff or surface loss potential, bird toxicity, bee toxicity, and beneficial arthropods toxicity. So as you see, it's taking elements from many different known targets, and it's trying to include different physicochemical properties of the molecules to try to come up with a metric to give an indicator of potential risk. And what you can find in our website is a list of more than 500 EIQ values for different active ingredients. But when you have a pesticide, so it can have an active ingredient, but the concentration can vary. So when you want to calculate the EIQ for a product, you actually are going to take the EIQ for that active ingredient and then multiply it by the concentration of the active ingredient and the application rate. So you can compare different products with the same active ingredient, but with different application rates or concentrations. So what you would see in our website is it's a calculator that looks like this, and you can write the active ingredient, the concentration, the application rate, and you would get something like this. I don't think I have time to go through the whole example, but I was comparing two fungicides. So I did a calculation for two fungicides, and as you see, for example, the first fungicide, Captain Gold, has a higher EIQ compared to the second fungicide. So this is really a tool to compare. So when of course, all the information in the label is important and you need to read it, but this is like a summary of all the potential, not all the potential risks, of some of the potential risks that a pesticide could have in the environment. So this is just a tool that could complement all the analysis and all the risk assessment that you would use when you decide to apply pesticides. And I just want to say, I just want to quickly add that another source of information is the pesticide property database. This is a database that is hosted by a university in the UK, and you can very quickly access to the information on pesticides, and you can just type the active ingredient and get a lot of information on the physical chemical properties, the environmental fate, and some of the potential impacts on human health and non-target organisms.
Great.
Yeah, I'll leave it like that. Yeah.
Great. Thanks so much, Diana. I know that was a lot to share in a very short period of time. I think, I think if you could just sort of summarize a little bit about how tools like this can be used to help inform community discussions as well, that would be really helpful. Just recognizing, again, that's part of what we're doing here tonight. So
yeah, I think the message that I would like everyone to take home is that that risk is this function of two things: toxicity and exposure. So when you're thinking about if a molecule is going to be applied in your area, in your region, the question that you should ask is not only what molecule, but also how it's going to be applied. Yeah, if people are going to be exposed or animals going to be exposed, and what type of equipment are they using? Are they using protection for the workers? Like these type of questions, because it's not only what are you applying, but also the quantities and the frequency and how the application method is done, because that would change everything. Like that would change the risk. And I think if people can be very careful and very thoughtful about the way a pesticide is applied, you can reduce the risk a lot, and also all the potential side effects. that, and also when thinking about pesticides, I guess you would need to take the same approach when you have to take a medicine, and try to outweigh the benefits and cost of doing that. Yeah.
Great. It's a helpful analogy. Thanks so much. Yeah, go ahead, Dan.
I just want to mention, so, this whole process of risk assessment, general hazard exposure is a conversation that goes on during the labeling process. So I'm not going to speak for the EPA, but for a product to be labeled, it goes through extensive process analyses to see what is the exposure. That is how a label is created for a pesticide, is via all these studies to say, all right, how can it safely be applied based on that hazard quotient or similar metric. So that is already kind of built into the process. I can speak for like the Forest Service. We have yet another layer where we do our own risk assessments called human health ecological risk assessments. Anybody's happy to go Google that with Forest Service and they'll come up, where we ourselves take all that data and develop a hazard quotient to say basically what Deanna is saying in detail of, given any particular application scenario, what is the potential concern based on all the empirical evidence, or not evidence, data we have for various taxa, humans, everything.
Great, thanks. I'd like to go ahead and start opening it up for some of our audience questions, and thanks to those of you who've already put them in the chat, in the Q&A, or voted for one that's already there. Mallory's going to help us sift through these. So Mallory, I'm going to go ahead and turn it to you.
Sure. And I might not take these in the exact sort of prioritized order, but we'll start to dig in and cover as much as we can. There was one question about monitoring and management, and whether this group would have recommendations of local organizations that could follow up on soil assessments to monitor soil health on Boulder County open space lands.
That's a good question. By health, do you mean like bacterial counts and how many ascomycetes or some other fungi are in the soil? Is that the question? There are labs that do that kind of work, but I'm not familiar with the ones right off the top of my head. I know people who do things like soil texture, organic matter, pH, all the nutrients, but the biological activity of the soil is something that is a little bit more specialized.
At the risk of doing a commercial for CU, our microbiologists have now can do the entire soil biogeome, do the DNA workup of the soil. You can get for $500 a pop. Well, it's probably gone up since the last time I heard. I mean, you can find out everything that's in there. So it's really expensive, but this didn't exist until just a few years ago. So this is a new era, and it would be, we'll see what happens with it, but it would be a fast track way of assessing soil biotic diversity responses to virtually any management treatment that's out there.
Great. Yeah,
I think this is Therese. I'm jumping in just because we recently did conduct a study on the soil microbes on our Ohio Valley Ranch, and it is available on our Parks and Open Space research page. So if anyone wants to Google it, you can go ahead and Google that.
And we've got one published as well for the land next to Heil Open Space that actually has the eukaryotic invertebrate composition to it. It doesn't have any chemical experimental in it. It's just cheatgrass versus natural ants. But yeah, we're quite proud. We were one of the first to get the entire DNA out of the soil on this.
Yes, thank you. And I think, Tim, if that's the one that you did with Alex Markovich,
No, this is
it's not. It's a different one.
Dorota Parazinska. She's now at the University of Florida, and also with Steve Schmidt's lab, he and among others at CU have gone gangbusters in developing soil microbial ecology.
That's great. Thank you.
Great. I know CSU also has great soil health resources, so we're lucky to have both CU and CSU right in our backyards here. Okay, Mallory, keep going with audience questions.
Yeah, I mean, there are a lot of questions around a similar theme that I know we may not have the exact right composition to go into depth on, in terms of, you know, impacts on human health, but I'll sort of tee up a question related to that. I think folks are flagging just concerns about the impacts of some of these chemicals on both human health and wildlife. Some concerns and questions about the relationship between sort of some of these chemical producing companies and the government. And so questions about trust are sort of abounding in the comments. But so reflections on those themes are welcome, but maybe to ask it as a question, just, you know, given some of those concerns about the use of herbicides, what can be done to make sure that they're used effectively and only when necessary? And is there any way to define when necessary from an ecological standpoint, given that that's more of the expertise we have here?
Dan, do you want to take that?
Yeah, I'm mulling it over in my head as you ask it, and inaction is an action for a manager. You know, the question of the threshold of when is it necessary? We have, and I'll just, as land managers as a whole, you have goals, priorities for a particular landscape, the outcome, what you would desire to be in that landscape. And the inaction action can result in further invasion, further degradation of the landscape, as opposed to trying to take a passive response, you know, doing manipulations to that landscape to try to encourage a particular composition of the community, or an active response of trying to target the thing that you feel is making that change, such as an invasive plant. We are tasked as land managers to identify when that is and respond accordingly. We won't always agree in exactly what that threshold is for, you know, the amount of the invader or the amount of disturbance before we want to take action. But it is a tough question that we are constantly grappling with. That's the balance that I kept trying to convey is, you know, you can always be responding to everything or taking no action. And we are just trying to strike that balance as land managers, somewhere in the middle, given the best evidence that we have, but recognizing that most of the time we don't have all of the information. I would argue that taking an action because you don't have all the information is itself an action.
I would also say that I'm speaking for myself, I'm not a toxicologist, but these products, whether you're talking about a fungicide, insecticide, herbicide, under the category of pesticides, go through a lot of evaluations. And the companies expend a lot of money trying to answer all of EPA's questions about toxicity to fish, to quail, to invertebrates, to Daphnia, to all sorts of different scenarios. They also do a lot of work on environmental fate. How long does a particular product last in the environment, and what are the breakdown products, and are any of those breakdown products potentially toxic to whatever? So I would just say that that information is out there, and it can be fairly easily found. The question is, how does someone who's not a toxicologist interpret it? That's probably the biggest thing, because there are a lot of numbers. They can tell you how many milligrams per kilogram body weight some product might take to impact a fish, a trout, or something like that. But what that really means in terms of the exposure of that trout in the natural environment is very different. The EPA also throws in safety factors. So they may say, we don't see any no effect level, but we're going to make sure that at 10 times that level, there's no effect. So there's a lot of safety built into the system, whether you like the EPA or not. They are there to try to help as much as possible to limit the people's exposure to any kind of product that might be detrimental. Those could be consumer products that are underneath your sink. Those would not be the EPA's purview unless they make a pesticidal claim. So you could see where some people are they take something like Skin So Soft that was really popular as to protect you against mosquitoes. That was something that the EPA probably would prefer that companies don't make, since there's not a lot of, you're making a pesticidal claim for something that's being sold as a body lotion. That's just the only example I could get off the top of my head. But again, it's really that these products go through a lot of testing, and we hear all the time that companies have products that they think would be very promising. But if there's one glitch in the toxicology package, they may kill a particular product that potentially had great value, just because it appears to have some sort of detrimental effect at these early stages. I'll just also say that the cost of registering a new product is probably somewhere north of $250 million to $300 million. A lot of that goes into the testing for environmental and human toxicology and all the other tox tests that get involved.
And I maybe would add that under registration process, not only the information from the company is taken into account, but also all the research that is published. Also, when EPA does the revision of the products every certain number of years, every 5, every 10 years, they compile all the information that is published, and that's part of the reports. Yeah. Of course, not everything is covered in the toxicological assessments, and there are things that there's question marks on how things might impact the environment, but it's very comprehensive, the registration process.
Tim, did you want to weigh in on this one?
All right.
I have, as an ecologist, I have opinions, but I have no scientific input on that.
Okay, great.
Okay. I think I'll go to a question in a second here just about alternative controls, but just since this one kind of connects, and you touched on this maybe some, Scott, in terms of sort of studies that are done, but somebody just asked about you talking about the visible impact of removing cheatgrass with herbicides to allow native plants to return. Have you done any studies on the invisible impact of herbicides? So, for example, does it negatively impact pollinators, other animals, the soil microbe, et cetera?
I know for a fact that, and I mentioned the study that was done by a woman who was at CSU. Her first name was Arthi, but I can't remember her last name, but she's moved on now. She's the only one I know that's looked very specifically and in Boulder County to look at the impacts of controlling cheatgrass on pollinators, and there it was very positive. As soon as you controlled the cheatgrass, there were more flowers, as I mentioned, more flowers per plant, more plants per unit area, and just all in all, more resources for native pollinators. I know that Boulder County is looking at some impacts on other trophic levels. For example, Joe Swanson and Jim Sebastian are doing some monitoring of shrubs in areas that have been cleared of cheatgrass versus those that still are competing against the cheatgrass. And there's a significant increase in leader length of the different shrub species that mule deer use for winter browse. Now, if you're going down into the soil, I don't have any information on that, but as far as impacts on things like deer populations, mouse populations, pollinators, those all show positive responses to the removal of cheatgrass.
And just to be clear, Scott, I think the part of that question was the impact of the herbicide on those populations. So were those cleared of using an herbicide, or neutral to the method of clearing the cheatgrass?
Those are all done with herbicides, but quite often we do more than one management strategy at a time. We often use prescribed fire with herbicides, and I think this case, let's see what. Oh, so I guess you would, if you wanted to see the impacts, I mean, just at the gross, how many how many deer there are per unit area. They seem to always prefer the area that was treated with to control the cheatgrass. I don't think anybody's taken blood samples or, weighed them or done anything like that to see if the herbicide itself had any impact, but the impact of controlling the cheatgrass is pretty pronounced.
Okay, thanks.
I think that we can go to. Oh, sorry.
I was just going to add, it's often, I don't know, my perspective is often on the net, in that given the action, there might be, if there is any, but there might be some direct effect of that particular application or any management action. But the indirect effect, I think, is what Scott is focusing on, of the control of cheatgrass in this case resulted in all these positive effects. So maybe there is some measurable minor negative effect due to that action, but on the net, because of all the positive effect of the reduction of cheatgrass in that case, you see an overall benefit to that landscape.
Okay, great. Thanks. And this next question may be for you too, Dan, around alternative controls on weeds other than cheatgrass. The question about, a citing of different times that open space staff use spray equipment on other weeds and the potential impact of those on aquatic life. So is there a setback from rivers and streams and irrigation ditches that is recommended for some herbicide applications? What kind of stormwater contamination measurements are set up? Just alternative controls, and it seems like sort of interest in hearing about things other than cheatgrass.
Sure, yeah. I mean, I can't speak obviously to their particular program. What I can say is that for any product you're using that is labeled a pesticide, there's going to be clear label language about potential water contamination and avoiding it via mitigating practices. I think that's kind of the primary question there, or was there something else to it? Because I don't want to speak to their program. I don't know their program.
I think a two-part question, Dan. One is, first, are there other safeguards that you put in place when using chemicals as a land manager that are sort of either good practice or best practice or usual practice in terms of timing, location, et cetera?
Yeah, so I mean, I'm going to give the perspective of my historical background in extension, where a lot of the questions that I would get from land managers was, I have problem X species, what do I spray on it? And it was always stepping back kind of to what you're describing, or maybe what the question's asking, of really building a holistic management plan of, what's your goals here? What strategies can we take? Maybe herbicides are one of the approaches, but can we be facilitating the desirable plant community via some other action, trying to reseed that area, in some cases tilling and things like that to break soil structure up, or fertilize. Like, there's all sorts of things to do indirectly. Targeted grazing is always of great interest as a potential strategy, other biocontrol type approaches. So there's all sorts of ways to approach it, but I guess what I would say is, my understanding of Boulder County, and please correct me if I'm wrong, much like the Forest Service, each of our management units has a management plan that has goals and how they likely want to get to those goals and the tools that are available to them. I imagine that that's kind of the intent of this whole process, is for creating a management plan that gives them the best tool set available to take action, so that they are being comprehensive in their approach and using the right tools, plural, for the right job. I think that might answer the question.
Yeah, no, I think that's helpful. Anything else from others on this question of just alternative forms of management, as well as the safeguards with any of those management pieces?
Well, I wish there were some other options for cheatgrass, but I mean, I've done biocontrol for years. In fact, my days at the University of Nebraska were geared toward all sorts of things dealing with leafy spurge, including the different flea beetles and other things that have been very effective in certain environments. Unfortunately, with an annual, I don't know of any biocontrol strategy that really works for annuals. Dan mentioned that he'd done work with the soil microbe, a bacteria. Unfortunately, I didn't have much faith in that, since I'd heard 20 years ago a fungus also released by the same person in Washington was going to end downy brome competition in winter wheat, and that didn't happen either. So it's always nice to have alternatives. You know, we've talked fire, we've talked prescribed gang grazing, other times of grazing strategies. And for many weed species, there are options, and those should always be explored. I'm certainly not opposed if a biocontrol agent is effective in managing a particular species. I'm 100% for it. I've done work on tamarisk, and the impacts that the beetle are having on tamarisk are pretty phenomenal. But then people started complaining, well, the yellow flycatcher isn't going to have any protection from predators if we get rid of all the tamarisk. So, everything we do as a management strategy has, can have unanticipated consequences. So I'm certainly not opposed to biocontrol. Anytime it can be implemented, I think it's a great strategy. But it is also not without risk. And I think I worked with a woman at Nebraska who showed that the Rhinocilus conicus, which was released for musk thistle control, also attacked many rare and native thistles that were common in the sand dunes in southern Michigan. So there are always risks, and one of our other speakers talked about the difference, risk versus reward sort of thing,
Just commenting on biological controls can also include plant competition. Our one-on-ones with cheatgrass in our meadow, we're finding a few plants that that what's shoving it out, since we have time series of our abundance through time, and can look at the composition of what's increasing, and while the cheatgrass is decreasing, there's some perennial grasses out there that appear to be able to shove it out over time under the conditions of our meadow. And I agree that, the Spatulauta is your person in Nebraska.
Yes.
And she's absolutely right. That weevil threatened a rare and endangered thistle up in the north porch someplace. But ironically, that same weevil has controlled musk thistle in Colorado to the point where you really can walk right by it. And the ones that survive are amazing pollinator feeders to both hummingbirds and a lot of insects. So that's the other weird thing that's happened with invasive species through time since I started this 30 years ago, is we've watched these plants and they come on with their bad boy reputations, sometimes rightly so, and sometimes unchanged through time. But others actually have become more benign through time, especially as the plant competition in North America, either native or other introduced sources of biocontrol suppress these plants. So, Scott, you worked on the spotted knapweed, showing how that progressed in some of the work. It started out as the wicked weed of the West, and now in some habitats it is controlled. But not in others. So the virulence of these things also changed through time, and that's even without factoring in climate change, which becomes a wild card to this as well.
Great. I want to go to, go ahead, Dan.
I'm going to ignore the climate change part because that is the wild card that is hard to wrap our heads around. But I will propose that for species to get to the point where they are in the system, there has to be something about them that is successful and establishes and allows that spread, take over, monospecific stands. There is some evidence, very limited evidence, to show that in some unique cases, you can have evolution of that community around it to better compete. Everything's evolving all the time, just at very slow rates, and you can have the plant community around it evolve in a way to deal with that invasive issue. But I would suggest overall that I'm hoping that we just let things be and they will come to a stasis and everything will be okay is a very risky move to take when it comes to our valuation of biodiversity and what that means for resilience of our systems in the face of climate change. So you got to be careful in saying, well, there's a couple species where they're not as virulent now as they were at some point. Well, something about them got them to the point of having massive populations across the area that they invade. To think that that just goes away is a risky approach to take.
I want to take some of the more some quick sort of fact-based questions around plants being pre-existing. That Scott, you've referenced, some of your work demonstrating that native species come back, and if you want to just explain a little bit how that happens. And then there was also another question of why is cheatgrass coming in with grazing? Is it a species that's used for grazing, or how does it actually get here? So maybe just backing up a little bit to explain both of those processes. And anybody can answer those, but Scott, if you maybe want to go first.
Okay. How it got here, we were not exactly sure, but it's been here since the 1880s. And so it probably came in on a contaminate. Somebody brought seed from the old world, and that seed was contaminated. There is DNA evidence that there have been multiple introductions, so it wasn't just one introduction. The other part was we often think about these sites being very, very degraded until we control the cheatgrass and realize that there are many remnant species that are just basically hanging on by a thread. And when we remove the competition, that moisture then becomes available for those plants later in the growing season. That's what I mean by these remnants. These are really remnant species that are being released from competition. That's where we see the greatest response from controlling cheatgrass. So that sort of answers both of those questions. We have done some reseeding work, and we're realizing that that's going to be a lot trickier. Not only the cost of the seed and the process of reseeding, but just getting the weather conditions right. I've done a lot of drill seeding along the Front Range, and I would say probably 1 year out of 5 we get lucky and we've got moisture at the right time and we get things to establish. But that's sort of the answer to where it came from. And how it spread is if you've never walked through some dry cheatgrass, it'll stick to anything, especially if you have shoes like running shoes that have mesh in them. That will be the most difficult thing you ever tried to do. So it sticks to animals, it sticks to equipment. Those are the main ways it gets transported around. And it's actually, in some cases, fire is actually beneficial for its propagation. In other cases, the buildup of the litter actually helps the plant, the next generation get started, because the seeds will actually germinate without being in direct contact with the soil, but they'll be in that layer of thatch, which has a lot of moisture. So the plant is very, very well adapted to our climate. And one thing, just to throw a little climate change, if our summers get drier and drier, that's only going to be an advantage to the cheatgrass, which will utilize that moisture much earlier in the growing season than our natives. And I'll also say that there are a number of similar species, similar plants with the same life cycle that are coming in all over the West. Ventonata, Medusa head, annual wheatgrass. Help me out, Dan. There's a couple others out there. Yeah. There are many of these species that we have this open niche where we don't have a native species that can compete directly with them. And I think that's why we tend to see this the situation just getting worse and worse. And if our summers, I've only been in Colorado for 27 years, so I don't know everything about the climate, but before 2000, those 5 years, maybe they were just wetter than normal. But we used to get monsoons that would come over in August, and I just haven't seen that kind of weather pattern for probably the last 15 or 20 years. So it does look like our climate is shifting much more toward the Mediterranean, where all the moisture is coming in the form of snow and early rain in the spring, and then we're turning off really hot and dry. Now, 2023 was a really wet year. As soon as I say that, we had this really wet summer. But that's my 2 cents on where it came from, and when do we see the best response of a native community?
Just quick input on the climate. So I hang around these folks a lot. The modelers, as well as the empirical data for the Front Range, show us pretty flat lined for our summer precip, with essentially a hint, but a non-significant hint of a slight increase in the spring. And what that, I mean, again, it's our increasing the evapotranspiration. It's not our changing precip. And since our data suggests it's a seasonality of precip that drives the cover of cheatgrass, I feel comfortable that we're going to have we will have a strong climate push in the cheatgrass story in the coming decades.
Thanks, Tim. Great. Mallory, back to you for other questions that have come up.
I wanted to flag a couple that are maybe just for Boulder County and see if anyone wants to respond. It may just be more for follow-up, but there was one suggestion that the county, should they be the ones continuing to spray herbicides, that they should also be monitoring and reporting on the soil and water health after spraying, rather than having that fall to external groups. So it's more of a comment, but wanted to bring that in. And then there was a question about someone said their family has 200 acres in Jeffco, combination of timber and meadows that have been grazed for 100 years, and a question there about how they can connect with a conservation land manager to help regenerate the land and reduce fire risk. So if anyone wants to respond to those, you're welcome to, but wanted to just bring those out as potential things for follow-up.
I would suggest talking to NRCS about the land management question for a couple of reasons. They have a lot of expertise, but they also have a lot of money, and they're willing to cost share many sort of management strategies. So I would definitely contact NRCS and see if there's any programs that they could participate in that might provide cost share.
Local extension too, or specialists can be a good starting point for tying in since we're the science panel, folks that have access to the science around these questions, and try to integrate that into your land management practices.
Thanks. There's also one that connects to something y'all acknowledged, and some folks have commented on it in questions too, but maybe kind of in a forward-looking way. Is there anything that could be done to foster better, collaboration among scientists, land managers, policymakers, et cetera, to improve the implementation of noxious weed management strategies, recognizing that conversation may not have been happening to the degree it could have to date?
So there's been some innovation from the federal managers that I've picked up over the web and internet, involving what they called co-production science. So the way to do it would be to put any program such as this one with a kind of an umbrella group, advisory or suggestory, not on the grounds management, but a co-production science where it's a mix of academics, managers, stakeholders, and the policymakers, and they collectively then get their goals, sort of focused. And if Boulder County's won an award with this, so that their fireshed program's a classic example. They've reduced, the catastrophic wildfire risk with this analysis and a program that's been ongoing for several years. So the model's out there. And I really do like there's been this idea of resist, adapt, direct as being a sort of a focus of getting all the management moving, especially again under a climate resilience umbrella.
Maybe to mention, things that already exist. So from a federal standpoint, I know a lot of other state and local agencies have a similar process. I think Boulder does too. Um, our environmental compliance process is intended to be a conversation with analysis for any action we take where the public has an opportunity to comment and give their input, but also, the expectation is there's analyses done with the best science available to direct those actions. So, based on those conversations, the federal government often has resources to try to answer those research questions, but it takes time. All this takes a lot of time to get that type of information in a meaningful way that can be used to direct management.
Thanks, both. Any other reflections on how to enhance that collaboration? Okay.
Yeah.
Oh, sorry. Sarah, were you going to that clarification question?
Mallory and I are tag teaming a little bit.
Yeah.
Diana, question for you if you're still with us. I know it's late and your children are probably turning into pumpkins, but just a question around how land managers should think about monitoring after every herbicide application, or can you rely on models and decision tools like the EIQ to help assure that there aren't adverse impacts? And if Diana's not there, if any of Dan or others, if you want to weigh in on that, that'd be great. I think we may have lost Diana, so. Okay, we'll come back to her if we see her back up. Again, we've asked her to do, it's after 10 o'clock her time frame, so we've asked her to do yeoman's work here. And then Mallory, I think there was also a question just regarding around sort of the longer term effects, again, weighing the toxicity on the target population versus, what these herbicides might be doing to seed banks or the soil microbiome over time. And are there things that we're learning about that that we haven't already addressed? So do we know about residual effects on soil and microbes at this point of the herbicides that we're looking at, or is that an area for further research that we need to look into?
I commented on another similar question to that.
Okay.
Just vaguely and broadly, that when doing it in the realm of plant vegetation management, it's often hard to tease apart the direct and indirect effects, because I think a lot of these questions are intending to understand what is the direct effect of that chemical on the microbial community. But often it is, well, I shouldn't say often, because it's definitely a field in its infancy. I had a student working in a lot of my sites for Dalmatian toadflax control in particular, where the effect of the change of the vegetation due to the treatment more likely impacts the microbial community than the direct effect of that particular herbicide. So teasing those things apart is really difficult, is all I'm going to say. So when it comes to the research of it, that was something that was not published because of the inability to directly point to the effect of the herbicide and the indirect effect on the herbicide on the plants that affected the microbial community. Because it's a connected relationship. The below ground, above ground relationship of the plant community and the microbial community is inherently tied.
Great. Thanks, Dan.
Diana did say she may be able to come back in a couple minutes, so we can maybe return to the question you asked, Sarah, but wanted to bring up this question from Mark around if there's examples from around the country where youth or indigenous leaders are leading on some land management practices, and if there's any chemical-free models elsewhere in the community, or elsewhere rather, where community is being connected to stewardship of the land.
That's a tough one. Not that I know of. I think there was some, back in the days when I worked with tamarisk or salt cedar, there was I think it was the Ute Mountain Utes, or I think down around Cortez, who had an opportunity to access some funding to do mitigation of their own design on their land, but I don't know. Honestly, I have no idea whatever happened to that. So that was my only real experience with working with a tribe. So that's about all I can say about it. I think there is money available, federal funding, and then it would just depend on the tribe putting together a management plan and getting it approved, and deciding if they want to do the work themselves or contract it out. I think there's a lot of options, but there may not be anybody, at the tribal level who maybe has that much interest. I think if there are people who are interested, I think there's plenty of opportunities.
It's not in this area, but we have an example in southern Montana of the Crow tribe that identified bentonata, another invasive annual grass, as impacting some of the values they have in the landscape, and reached out to partners to help them with management, and to work in conjunction with them on how to approach that. So that's kind of a new program in its infancy, trying to be in a partnership.
Can I jump in here too? We in Boulder County have been expanding our collaboration with Indigenous communities, and we are looking at co-creating an area where we might be able to welcome buffalo back to county open space. And I think it's promising, and it's certainly going to take collaboration from the tribes and from us on how we co-create that and how we manage the vegetation effectively. And I know we've got partners in the area, both in Larimer County and down in at the federal land, Rocky Mountain Arsenal, that have buffalo as well. Yeah, so we're looking forward to expanding our collaboration with Native tribes on ecosystem management.
Thanks, Therese. We are getting close to the end here, so we are I'm just making sure I'm not missing anything question related here, but I wonder if we have I want to leave just a minute or two for you all to offer any closing thoughts or words of advice to Boulder and to the community as we look towards the bottom of the hour here. But also just want to ask, in terms of further research that you all would like to see, if there was one sort of research question or study that could be funded to answer a question that we don't currently have the answers to, what would that be? Sorry, you have to choose just one, Tim. I can see you smiling.
Yeah, it's coming out of the woodwork like that. I'm trying to think what's the most critical transformation that's going on. Ironically, in my background, I don't want to go there, but because I am a weed manager and have 500 acres that I'm responsible for, I've actually seen a transition and a new species out there that scares me. And I, as a scientist, would therefore probably go after it. But in terms of a priority activity, the biggest bang for the buck, to me, like I said, it's looking for those win-win-win pests where you can accommodate the climate resilience, the biodiversity advantages, the ecosystem services, while you're taking on something that folks don't like for some potential reason. But I don't know what would pop is on the top of the list for that.
Okay, thanks.
So I would say research around the idea of identifying priority landscapes that are critical and are at most risk. So we have things like ecological niche models, which their whole intent is to identify where any particular species is most likely to exist on the landscape based on environmental characteristics. But I would take that a step further of, where not just it can exist and not exist, but where is it most successful and least successful, to really get a sense of prioritization of various problematic, nuisance, noxious, invasive, whatever you want to call it, species, and where we should really target our resources. The invasive plant management community has very limited resources and a large amount of acreage to be trying to decide where to best spend those resources.
I guess I would go along with Dan's idea. If you could identify some really pristine areas of high value, and go and essentially develop a plan to protect them, that's probably going to be the way you could spend a certain amount of money more effectively. It's always it's hard to put a dollar value when you prevent something from happening versus trying to mitigate something that's already happened. I'm just reminded of a weed that we almost ran into, well, that could have impacted the whole Colorado River Basin, and that's a plant that's affecting the Columbia River Basin. It's called flowering rush. So I think putting more emphasis on trying to prevent the spread of weed species, both terrestrial and aquatic, would be a good place to spend some money, and also public awareness. You know, it's one of the big things that the whole citizen scientist program has really helped to develop, and that is, you know, people are now knowing what to look for, and I think that's and taking an interest in it, and I think that's going to help us in the long run to start to mitigate and prevent these invasions from even getting started. So the flowering rush invasion could have happened right out of Grand Junction, but we had some people that were aware of what the plant was, contacted CDA. They dug up the plant, did a bunch of surveys, and are now monitoring that particular drainage ditch in Grand Junction to make sure that the plant doesn't get started in the Colorado River Basin.
Thanks. Mallory, any last questions from the audience before we give everyone one last word before we adjourn here at 8:30?
No, I didn't know if we wanted to return to the question for Diana now that she's back as maybe her final question. And then, yeah, we can go to the final words of wisdom from the panelists.
Great. Yeah, Diana, I think the question was around how to use tools like EIQ to assure that no harm has been created if the EIQ is showing a relatively low harm level. Is there additional monitoring or sort of research that needs to go back to a site, or can you just trust the models to say we're pretty confident that this looks good?
Yeah, no, the EIQ and other pesticide risk indicators are decision support tools. So when you are deciding among different molecules or products, so it's to take decisions in advance. But of course, all the effects needs to be monitored in time and space, and it's very important to support like and pesticide analysis in the future, so residues in the soil, maybe in leaf tissue, and also like monitor key species for the ecosystem. So yeah, monitoring after application and after a managed program has been implemented is really key. So I think that's something that needs to be kept in mind, yeah, and in action. But yeah, definitely this is just a tool to make decisions at the beginning, and it's not an assessment of the impact afterwards. So they need to happen. Yeah.
Great. Thanks so much. Well, I'd love to give you each a minute or two to share any closing thoughts or parting words. I'm sure you know how to get a hold of Boulder County, and they know how to get a hold of you. So this isn't necessarily the end of the conversation, but for this evening, it will be. So any last thoughts that any of you want to share? And Diana, maybe we'll go with you first since we made you wait to last.
Yeah, no, I would say that applying pesticides is not the ideal scenario, but there's some context and conditions that might require to do it. So we will just have to make the best decision and try to select the less risk product for the context. And I know there were a lot of comments that it's hard to trust information that was provided by the companies, and like, but you know, there's not only information from the companies out there. There's a lot of peer review publications. There's a lot of databases out there that are also sources of information about pesticide toxicity and hazard and all that. So there's information from many sites out there to do to support your decisions.
Thanks, Diana. Scott, do you want to go next?
Sure. I would just say that I am somewhat biased because I have a lot of experience in Boulder County and working with the Boulder County crew. I think they do a fantastic job, and I think they're trying the best they can to answer all the concerns that inhabitants of the county of Boulder may have. We're never going to get everybody on the same page. That's probably an understatement. But I think just having things like this and being as honest as you can be with the different factions or groups of people in the county is probably the best. And I would think if people were willing to go out on field tours, I don't know if the county is still doing one, but when we had our field tours, we always had great responses from what people could see with their own eyes on the ground, made a big impact on how they felt about a certain management strategy. So maybe the county could think about having people come out and look at some of the different properties and the progress the county has made in improving the diversity and the quality of the different properties that are managed by Boulder County Open Space.
Great. Thanks, Scott. Tim.
Okay, well, just some intro. You know, I'm not have any experience in weed management in agriculture. My focus is on natural and semi-natural areas. But I was given the charge by a land manager 20 years ago to take on a large portion and go non-chemical with it. So I've been challenged to say what are the consequences of going non-chemical. I do think that a largely non-chemical or no chemical, weed management program can be implemented. There will be consequences, and one has to work through the winners and losers on that. I should point out that Dr. Bob Breckenridge, who's a researcher at CU, has already provided a draft management plan for the commissioners of how this would be done. And I actually, having looked at it, think it's in pretty good shape. Again, it would have to be scrutinized and to evaluate what you're going to win, what you're going to lose. But again, taking this on with a co-production science team of academics, managers, and stakeholders, I think is the best way forward and is the future of weed management for Boulder County.
Great. Thanks, Tim. Dan, we'll give you the last word.
Yeah, I'm not going to speak to Boulder County specifically, but I'm just going to reiterate for land managers as a whole, we're given a near impossible job of trying to make these decisions and interpolate from all the information that doesn't exist where we are exactly or doesn't exactly fit the scenario to come to best management decisions. In some cases, that can be not using a herbicide and using some other management approach. Integrated pest management is the whole principle philosophy of that. In other cases, in my experience, the option that tends to be viable and realistic at the scales that we operate for large land managers is something like a herbicide. So it is one tool of many. It is often used because of its efficacy and its targetedness, but it is one tool that we have in our tool belt and should respond accordingly, sometimes with other tools.
Great. Thanks, Dan. And Therese, when I give you the final word, if there's anything else you want to share with the group before we close out here.
Well, I certainly want to say that a lot of the points that you brought up, Boulder County really does implement. We use a lot of mowing. We use a lot of monitoring, catch it before it gets out of control. We use hand pulling where it's appropriate. We've used targeted grazing. And I really do appreciate the idea that we need to have all the tools in the toolbox if we want to effectively protect the amazing biodiversity we have here in Boulder County. And we've done Colorado Natural Heritage Program assessments of the biodiversity in Boulder County, and we have species on our open space that are globally rare. And those are the ones that we really do want to protect. And we have those outlined. We have maps that show where these areas are. So again, talking about comprehensive management planning that will get us to the targeted outcome that we want, we really do need all the tools. I just want to thank the panelists. That was really, really insightful, all of you with all of your experience. I really appreciate you coming out. We've had a huge amount of people in the audience listening to you. So thank you very much for participating, and thank you to everyone in the audience for listening to this science panel.
Great. Thanks so much, everyone. We hope you have a good rest of your evening, and thanks again to our panelists.
Bye now.
Thanks.
Thank you all.
Everyone.
All right.